Hello, this is the solution to quiz 10. So let's take a look at the first question. So convert 1.735 meters to feet to the proper number of sig figs, in addition to the provided conversions on the front of the exam. Okay, this is from an old exam, but they also give you some conversion factors here. You may also just use the chart of additional information that I have provided. So if we're going to convert this to, what do we want to go to again? They're going to feet. So number of feet, what we're looking for, 1.735 meters. The one conversion, you're going to get this off the chart, not on this test. Let me have it pulled up. Where is it? So length, you would be given the conversion, if you need it, that 1 meter is a certain number of yards. So 1 meter is equal to 1.0936113 or 133 yards. So we can start with that. So 1 meter is 1.0936. And if I carry like one more digit on that conversion factor, there's more units given, but it seems like that would be not necessary. Maybe we'll use 2 more, just to be really careful. So that goes to yards, and we're told 1 yard here is 3 feet. And then that is actually all we need. We don't even need the foot to inches, because we're just going to feet. Okay, so we go from meters. Now, a meter is almost a yard, as you can see. So 1.735 times 1.09361 times 3. So I get 5.692 feet. So the key here would be that this is, whether or not that's exact, it's hard to know. You know what I mean? Like when you see a conversion factor that's out to like 6 or 7 or 8 decimal places, it's hard to know if that's the full exact value, but still, it's more exact than our measured number of meters that we're converting. So we're still keeping 4 sig figs. This is an exact conversion. Whenever you see like 16 ounces is a pound or 3 feet in a yard, those are exact conversions, just like exactly 100 centimeters in a meter. So we're keeping all 4 digits as significant here. Atomic symbol for an atom, 47 protons. So the symbol there would be Ag, so that's a silver. 61 neutrons, 46 electrons. So we have 1 fewer electrons than protons, so we have a net positive charge. We have fewer negative particles, so we have silver plus. And then our mass number here would be 47 and 61 added together, so that would be 108. So 108 Ag plus. 2 atoms of the same element must have what in common with each other? Mass number. So 2 atoms of the same element, something like carbon 12 versus 13. So these are 2 different atoms of the same elements, 2 isotopes. They differ in mass number, so they're not going to have the mass number the same. Atomic number, that is what makes atoms of the same element, is that they have the same number of protons in their nucleus, not both of these and not neither, so just the same atomic number. So number 4, another sig fig problem. Okay, this one's using scientific notation, and this is a good reminder here that if you put this into a calculator, that's where you might have a bit of an issue. See, you have hundredths place plus hundredths place. If you put this into a calculator, let's do that real quick. 4.49 times 10 to the 3 plus 7.13 times 10 to the 3. If you put that over in scientific mode, so your calculator shows the scientific notation, my calculator shows 1.162 times 10 to the 4. Okay, so now you might think, okay, hundredths place plus hundredths place, so we should round here. But that's not quite right, because one's times 10 to the 3, the other's times 10 to the 4. Think about writing these numbers out as their whole numbers, like 4490, ending in the 9 for 3 sig figs, and 7130. So that's 4.49 times 10 to the 3, and this is 7.13 times 10 to the 3. Add these up here, and you get 11620. And so if you look at your placeholders, we should round these to the tens placeholder and keep that 2 as significant. So all 4 of these digits are significant. So doing the summation here, we end up with 4 sig figs. Divide that into 4 sig figs, we're going to keep all 4. So the answer would be A. Okay, so don't let scientific notation confuse you. If you have to, just write the numbers out as whole numbers. Line up your decimals, like line the numbers on top, so that you can sort of clearly see where the digits are good to, and then round that result to the same placeholder as the value that's sort of greater in the quantity of that last placeholder. Number 5, select the combination of statements which are correct. The mass number of an atom is the sum of the neutrons and protons in the nucleus. That sounds right to me. The number of neutrons in an atom is its atomic number. No, it's the protons. The isotopes of an element differ only in the number of protons. Nope, they differ in the neutrons. The volume occupied by the nucleus is a small percentage of the total volume of the atom. That is true. The nucleus is very small. The electron is a very small, not very massive particle, occupy the greatest volume of the atom. The number of electrons and protons in a neutral atom are equal. That is true. So it looks like we got statements 1, 4, and 5 are true. Or no, statements 1, 4, and 5. All right, so let's head to number 6. Which of the following statements is correct? A heterogeneous mixture must contain at least 3 elements. You could have a heterogeneous mixture of 2 elements. Like you could have, like helium on top of like a metal or something like that, so that you could have a gas. So this would be a heterogeneous mixture, different phases of just 2 elements. That doesn't seem to be true. A mixture containing 2 compounds must be heterogeneous. That just seems nonsense. You can have mixtures that are homogeneous or heterogeneous that contain 2 compounds. A homogeneous mixture must be uniform. Yes, that is the meaning of homogeneous, is that it is uniform throughout. And the pure substance must contain only 1 type of atom. No, a pure substance could be a compound or an element, which could contain, if it's a compound, 2 different kinds of atoms. A compound may contain only 1 type of atom. That is not true as well. So if you have something like O2, this is not a compound, that's just a molecule. To be a compound, you have to contain 2 elements. So just statement C. What is the proper formula for the ionic compound comprised of sodium, cations, and oxide anions? So this is just the common ion of sodium, common ion of oxygen, so 2 sodiums to balance out the charge, so Na2O. Which compound below is zinc 2 phosphate? So that's zinc 2 plus is zinc 2. Phosphate is a 3 minus, PO4 3 minus. We got to memorize the 4 and the charge for phosphorus. And so then we're going to do 3 zincs and then 2 phosphates to balance out a 6 plus and 6 minus, so that we have a charge neutral compound. So Zn3PO42. What is the formula of carbonic acid? So carbonic acid, the ic acid, means that we're looking for carbon 8 as our underlying ion. So that's a CO3 with a 2 minus. So this is going to be H2CO3. So we just kind of go to the ic acids. We're looking for the 8, carbon 8 ion. So write out carbonate, add enough H pluses to balance out the charge. So it'd be H2CO3. What is the formula for hydrogen phosphate ion? Hydrogen phosphate. Now let's think of it this way. Phosphate's a 3 minus. We're adding an H plus, so that kicks the charge down to a 2 minus. So you're kind of going to this ion with its usual charge, adding an H plus, kicking the charge down by a unit, and then writing that formula. So HPO4, 2 minus. So HPO4, 2 minus. All right, that's all for this quiz.